Good morning students. This is the video for class 11th and the chapter which is going on is Newton's laws of motion. So this topic is connected motion, which is in the continuation for continuation after second law is the real law of motion. So is in this topic what we will do, we have to consider the two bodies of masses m1 and m2 tied at the ends of inextensible string. So you can see that in this diagram these two strings are inextensible, so which passes over a light and a frictionless pulley. Which kind of pulley we are using? We are using a light and a frictionless pulley, so that our string can smoothly move over this pulley. So what we are supposed to do, let us consider that two masses are hanging at the end of the terminals of the two pulleys. And what is the relation between the two masses? M1 is greater than M2. So here I am writing the relation that M1 is greater than M2. Okay. So what is happening here? So the heavier body, we all know that if the heavier body is hanging at one side, so our whole system is gonna move in the downward direction in that from that part. Okay, so the heavier body will move downward and the lighter body will go move upward. So in this condition our M1 is heavier, so this pulley, this string will go downward and this string will go upward. Okay, so let A be the common acceleration of the system of the two bodies. Let the system is moving with the common acceleration, but this mass is moving in the downward motion with an acceleration of A. Okay, and this mass is moving upward with an acceleration of A. Okay, we have taken A as a common acceleration. So since the pulley is light and frictionless, so therefore the tension in the string shall be the same on both the sides. Since the pulley is frictionless and the same string we are using, so what can we say? We can say the same tension is working on both the strings. So here let me name the tension as T, and we all know that tension always works opposite. So here the tension is working here in this condition, and as well as here the tension is working in this condition in this diagram. Okay, so let us consider the two bodies separately. On heavier body, we will see how many forces are acting on the heavier body and how many forces are acting on the lighter body. So on the higher body side, the various forces are, so number one, if I will consider the heavier body, so case 1 for heavier body, if I will consider, so for heavier body what I can see, number one, its weight m1g, that is that always act downward. So in this condition I can write down m1 is acting downward. So what will be the weight of this body? Suppose if I am naming this as w1, so it will be m1g. So first force which is acting over here is m1, that is m1g. And what is the second force which is acting? That is the tension T in the string, which is acting upwards. So second force I can see, that is a tension T that is acting upwards. So as the body moves downward with acceleration A, we can see this body is moving downward with acceleration A. So the net downward force on acting on this body will be ma. We all know that according to Newton's second law, that will be ma. So since mass is m1, so I can write down the external force which is acting, or the net downward force which is acting on the system is 3. I can write down net downward force which is acting can be written as F is equals to m1a, which is acting downward. So ultimately, clearly, if I want to write down the equation, final equation for the heavier body, so I can write down the final equation as, since the whole system is going downward, so our m1g is greater than the tension. And how much it is greater? It will be greater, that will be equal to the m1a, that is net downward force. So I can write down, so m1g will be greater than t, that is minus t, and how much it will be greater? It will be equals to m1a. So this will be the equation, or we can say this will be the first equation we are considering when we are talking about heavier body. Now suppose if I will talk about the lighter body. So in the case 2, what I will discuss about the lighter body. So in the case 2, on the lighter body, how many forces are acting on it? So first of all, we all know that our weight will gonna act on that. So suppose I am naming the weight as W2. So in which direction our weight will gonna act? Our weight will gonna act always on the downward, and that will be equals to W2 is equals to M2G. So if it is M2G, then W2 I can write down here M2G. And what is the second force which is acting right now in this on this mass? That will be the tension, and that is acting on the upward direction, so by the string. And lastly, as the body moves upward with an acceleration a, so the net upward force on it will be M2a. So the net upward force will be acting, that is I can write down the third force, that is net upward force, that is acting on the system of the second mass. It can be written as F is equals to M1A, sorry, M2A. Okay, so if I want to write down the final equation for the lighter body, so I can write down, as we all know that tension in this case is greater than M2G, because the whole system is going in the upward direction. And how much it is greater? So it can be written as tension minus M2G, and how much it is greater? It is greater than, is equals to net upward force, that is M2A. So this equation can be written as equation number 2. First equation is for heavier body, and the second equation is for lighter body. So if I will add both the equations, so here if I will add both the equations, what I will get on the LHS side, if I am adding, so it will be equals to M1A, or M1 I should write M1A plus M2A. Okay, so I am writing M1A plus M2A, and in the left hand side if I will write, if suppose I am keeping it here, so if in this condition if I will write M1G minus T plus T minus M2G. Okay, so here you can see I have written in this way. So our M1A plus M2A is equals to M1G minus T plus T minus M2G. So from here the T is T been cancelled. So here I can write down, if I will rearrange the things in this condition. So what can I write? M1 plus M2A is equals to M1G minus M2G. So from here I can take the G also as a common, so I can write down M1 minus M2G is equals to M1 plus M2, make it open as A. If I want to find out what is the total net acceleration in the whole system in this condition, so our acceleration formula comes to is M1 minus M2 upon M1 plus M2 multiply by G. So this is the formula for the acceleration of the whole system when the two masses are hanged according to the string, okay, on a frictionless and a very light inextensible, with the help of inextensible string over a light and a frictionless pulley. So this is the formula for the acceleration. But clearly we know that our acceleration of, that is A, of the system of the two connected bodies is always less than the acceleration due to gravity. Means we can say that our acceleration can never be greater than the acceleration due to gravity. Our acceleration is always less than the acceleration due to gravity. So if I will divide both the above equations, okay, if I will divide equation 1 by equation 2, so what can I get? I can get on the left hand side, if I will divide, that is M1G minus T upon T minus M2G, and that will be equals to M1A upon M2A. In this condition, what I can get the value of the tension, means how much tension is working on that string, okay, in this condition. So if I will cancel out on the RHS side, if I will cancel out M1 and M2 from there, okay, and then if I will multiply both the side, means if I will rearrange the things in either of the sides, sorry, this M1 and M2 is not been cancelled, our acceleration is been cancelled, our M1 and M2 will remain as it is, okay. So when I can write down the equation as M1G minus T multiply by M2, and here our M1 is multiplied by T minus M2G. So this will be equal to, if I will multiply internally, it will be M1 M2G minus M2 T is equals to m1t minus m1 m2g. So here, from here I want equation of t, so I will bring all the t terms in one hand side and other terms in second hand side. So since there are here m1 m2g in this condition is positive, in this it is negative. If this term will go in the left hand side, so it will become 2m1 m2g, and in this condition if t minus m2t will come in this side, so I can take out the t common and I can write m1 plus m2. So from here I can get the formula of tension. Tension will be equals to 2m1 m2g upon m1 plus m2. So this will be the formula for the tension in the string. From here we can find out or we can calculate the tension in the string. Thank you.